Hello everyone. In previous session, we discussed about the creation and display operation on single linked list. Now we are going to discuss about the insertion operation on single linked list, where the insertion operation can be performed on 4 different ways. Like we can insert a new node at the beginning of the list. We can insert a new node at the end of the list. We can insert a new node after a given element, and also we can insert a new node before the given element. Let's discuss each insertion operation in detail. Insert a new node at the beginning of the list. Let's take an example of a linked list which is having 3 nodes, where the first node is referred by the name head and the last node is referred by the name last. Now insert a new node as the first node into this linked list. For this, allocate a memory for the node structure and refer that memory with the name n. Now insert a data value as n arrow data equal to 40, and whereas coming to the next part, you need to attach this before the head, then the next part should hold the address of the head. Then a link will establish between the new node and the head node. After attaching the new node before the head, then the new node should become the head node by doing the assignment head equal to n. Let's see the implementation. Insert begin. First, allocate a memory for the node structure. Then a memory will be allocated for the node structure, and that will be referred with the name n. Insert a data value into the data part as n arrow data, and make the n arrow next should hold the address of head. Suppose the head is situated at the position 1000, then this should be assigned with the address 1000. Then a link will establish between the new node and the head node. Now you need to make this new node as the head node by doing the assignment head equal to n. Now this new node will become the head node. This is the procedure to insert a new node at the beginning of the list. Now we'll discuss insert a new node at the end of the list. Take the same example of a linked list with the 3 nodes. The first node is referring with the name head and the last node with the name last. Now insert a new node at the end of this list. Now allocate a memory for the node structure and refer that memory with the name n. Insert the data value as n arrow data equal to 40 and make the next part as null. Now you need to attach this node at the end of the list. In that situation, you need to establish a link. You need to give a link between the last node and a new node. In that situation, you need to store the address of a new node into the last node by doing last arrow next equal to n. Now, after attaching this new node at the end of the list, this new node will become the last node. But here, the node which is at 3000 is referring with the name last. Hence, you need to move last from 3000 to 6000. Here, the 6000 name is n. So, just you do the assignment like last equal to n. In that case, the last node will be referred with the name last. Now see the implementation. Here, allocate a memory for the node structure and refer that memory with the name n. Insert the data value, suppose like 40, and make the next part as null. So already we have a last node with some data value. Okay. And here, last arrow next equal to n. Then a link will establish between the last and n. Now, after attaching the new node at the end of the last, you need to move last to the new node. That is by doing this assignment. Now, the last is pointing to new node. See the another insertion operation. Insert a new node after the given element. Take an example of a linked list with 4 nodes, where first node name is head and the last node name is last. Now here insert a new node 50 after 20. Now in this situation, you need to search for the element 20 in the above linked list. That we can do with the help of the temporary pointer starting from the head node, where temp is pointing to the head location, that is 10,000, that is 1000, where temp arrow data is 10. It is not equal to 20. In that situation, move temp to next node here. Now temp is pointing to next node. Now the temp arrow data is equal to 20. Hence, you stop moving the temp pointer. Now this node is a temp, whereas this node is temp arrow data. You should be very temp arrow next. You should be very clear about the names of nodes. Here, this node is a temp, whereas this node is temp arrow data. Now here, what you do is you allocate a memory for the node structure and refer that node with the name n, insert the data value, something like 50, and whereas the next part here, it should store the address of temp arrow next. The address of temp arrow next is 3000. So by doing this assignment, n arrow next equal to temp arrow next, you can make a link between n and temp arrow next. Now you need to give a link between temp and n in such a way that store the address of n in the next part of temp, just by doing the assignment temp arrow next equal to n. So in this manner, we can insert a new node after a given node. Just see the implementation here. Allocate a memory for the node structure and refer that memory with the name n. Insert here, we are reading the data value and insert the data value into that data part and make the next part as null, where here you need to take one more data value which you want to insert after this given key. Now start searching for this key from the head. Hence you need to take the temporary pointer starting from the head, and while that means here you need to iterate some statements till you reach end of the link, where you need to search for the key. If you are able to search for the key, come out of the loop, or otherwise move temp to next node. Now attach a link, right side link, where we are storing the address of temp arrow next in new node, and here for the next assignment, here we are holding temp arrow, the new node into the temp arrow next. Look into another case, insert a new node before the given element. Let's take an example of a linked list with 4 nodes, where the first node is referred with the name head and the last node with the name last. Now, here take the example that insert a node 50, insert a node with the data value 50 before the node 30. Here the key is 30 and the new node is 50. Now here what you need to do is, again you need to search for the given key with the help of the temporary pointer starting from the first node. Here we are taking the help of another pointer, that is previous. Here the previous is used whenever we are moving the temporary pointer to the next node. That temp information we are holding in another pointer, that is the previous pointer. Let see this implementation, where here the first node we are referring with the 3 names, that is head, temp and previous. Here what I am doing is I am checking whether this temp arrow data is equal to 30. No, it is not equal to 30. In that situation, you move temp to next node and initialize temp with previous. So the temp information we are storing into another pointer, that is previous. Now here the temp is 2000 now. The temp arrow data is 20. Is it equal to 30? No, it is not equal to given key. What I'll do is I'll store the information of temp in another pointer, that is previous, and I make a move of temp to the next node. Now the temp is 3000. What is temp arrow data? Temp arrow data is 30, which is equal to given key. Now stop moving the temporary pointer. At this situation, the temp is 3000, previous is 2000. Now what you do is allocate a memory for the node structure and refer that newly allocated memory with the name n, insert the data value as 50, and here, whereas coming to now, after this you need to give links between n and temp, and as well as between previous and n in a simple assignment with the help of simple assignment, where just n arrow next, equal to temp. Now here this n arrow next is holding the address of temp, that is 3000, whereas the left link is this name is previous, and this part is previous arrow next, hence previous arrow next equal to n, the n is 8000, hence we are storing the address of n into previous. So this is a procedure to insert a new node before the given element. Let's see the implementation in C. Allocate a memory for the node structure. Insert the data value. Make the next part as null. Now read a key. Search for this key starting from the first node till you reach end of the list. Search for the given key. Whenever you search for the desired key, then you come out of the loop, or otherwise store the temp information in previous and move temp to next node. Here give the right side link, that means give a link between n and previous, that previous arrow next, or this you can take it as a temp, no issues, n arrow next equal to temp, and then give the link between previous and n in such a way that previous arrow next equal to n. This is about the insertion operation on singly linked list. Just we'll take the previous program where we have already performed the creation and display operations. Just we'll try to perform the insertion operation. Include 4 functions like insert underscore begin to insert a new node at the beginning of list. Then insert underscore end to insert a node at the end, to insert a node after. Take one more function, insert a node before the given element. Likewise, you declare 4 functions and you change the menu options. Include, insert, begin, insert last, where 5 is insert after, and then the 6th one, last one, is insert before given element. Now read a choice and include these cases. The function calls case 3, insert underscore begin, and then give break. Then case 4, insert underscore end, then case 5, insert underscore after, let's break. Case 6, function call insert underscore before, and then break. Let's change this value 2 to 6. Now write the implementations one by one. Void insert underscore begin. Your B is small. Insert underscore begin. Same as usual procedure. Just allocate a memory, insert the data, make a next part as a null. Afterwards, you attach head to n and then move head to first node, the new node. Now write the implementation for insert underscore last. Again, the same procedure. Then the last arrow next equal to n, and then last equal to. So this is to give a link between last and new node, and this is to move the last pointer to new node. Now next, void insert underscore after. Now here you need to take a key value and the same procedure, and then read a key value, printf, enter value, after which to insert new node. Now we'll read a key value, ampersand key. Next, after reading the key value, then you need to search for that key in the list. So that we'll do starting from the head node, temp equal to head, while temp not equal to null till you reach end of the list. If temp arrow data is equal to key, then you take a break, come out of the loop, or otherwise move temp to next node, temp equal to temp arrow next. Next, after coming out of the loop, then you give links between in, temp and temp arrow next. First give the right link. So in arrow next equal to temp arrow next, and give the left link in temp arrow next equal to m. Now void insert underscore before. It's the same thing. Here you need to read a key, declare key, but instead of after it is before. Now again start searching for that key from the first node, temp equal to head. Now while temp not equal to null till you reach end of the list, search for the key. If of temp arrow data is equal to key, in that case take a break. Else what I am doing is store temp into previous equal to temp, and move temp to next, temp arrow next. Yes. Now come out of the loop and give links between n and temp, like n arrow next equal to temp, and left link like previous arrow next equal to n. So now we have done with the implementation. Let's see the execution. Here give the choice as 1, create node 1 with data 10, and again create node 2 with data 20, create node 3 with data 30. Print the linked list. So it is taking 3 data values, 10, 20, 30. Now you implement insert begin. Insert a new node at the beginning. Give the choice as 3. Insert a new node with data value 40. Let's see the contents of linked list. See, the new node is attached at the beginning of the list, 40. Now implement insert last. So enter the data value, which is 50, and give the choice as 2. See here, 50 is inserted at the end of the list. Now give the choice as 5, implement insert after. Here I am inserting the data 60, and after I want to insert it after 20. See here, see after 20 you have inserted 60. Now let's implement before by giving choice 6. Enter the data. Here I am giving the data as 70, I want to insert this before 60. Let's see the output. You see here, before 60, I have inserted 70. This is the execution of insertion operation on singly linked list.